start. All right, so what we're going to do is I'm going to put a couple of problems up here on the board, and I want you guys to talk to each other to see if you can find out what those answers are. Chantal, question.
So I did everything but one question on homework, and now that I go back to it, it's making me redo the whole entire assignment. It just says try again. It doesn't let me.
All right, well, I'll take a look at that, but we'll do this first, okay? So we're gonna mute this, and we're gonna try this to start with. If n is equal to 10, x is equal to 3, and p is equal to 0.7. Probably. All right. So I want you to work on this, see if you can make it happen. And if you need help from somebody, you might do this. Now, once again, I want to emphasize this. If you're trying to start this from scratch, that's a bad idea. What you should do is you should look at what we did previously and see what the formula is and see how it was done in class before. And then see if you can make that to work. And if you can't make it to work, what I want you to do is to find other people around you to talk about it, all right? We'll start there. Okay, let me see. Okay, so you're on number 4?
Yeah, but this is just how.
Oh, okay, so you want to get out of there. All right. Look on that. Give me a second.
I look at the hole and then I just.
But
I wish I just had the. I got 0 as well. Did you do,
well, see, I don't know where that other one is. So,
Is it?
okay. You don't want to save it for later.
Is it time? It was like this one, we created this, the 30 and yep, and we always had 30. So it's not a very full population. Because 30 was the number.
The trouble is that if you don't save
So the
it,
population is.
there's no.
Oh, yeah, but I started with this, I put, I did 10, and then the thing. and
Well,
then
okay,
3.
but
Oh.
what I would have wanted you to do is just close that.
3, and then I got the
Instead of
120.
saying
Okay, that's what, yeah, 3 got that, and then I did 120.
So,
Times 1, like, 0.7.
okay, all right.
Third,
So,
0.3.
yeah.
I got 0.
right.
Oh.
So,
Yeah, okay, not.
the only thing I can do is call.
Is that the.
I'd be easier. But I can't do that. I can't do that.
Right.
Oh, yeah.
So this isn't due until.
It was like.
So after we get done talking at the end of this class, then I can call them.
That's what I got too, yeah.
Well, see, if, when you say, I can adjust it,
Yeah.
but I don't know that I can have you 5, 6, and 7.
What am I doing?
Well, you could, because I see it right now. You have one. Right, and then, yeah. Sure. Yes, that would work.
Like try that.
And then you just right there.
Okay.
Today I ate chicken chips. I want chocolate and then I'm like, I do so good because I have this little like powder donut. Got a roll of myself.
3, 7.
Oh, okay.
Okay, the answer should be 0.009. Okay? If you have that, we're good. If you don't, then there's a problem, but we want to make sure that we know how this works. Okay? Elena, can you tell me what the formula is for this?
Like this time?
Yeah.
I don't know how to say it.
Okay, I have P of X, and then I have an equal sign. I want to know what comes after that.
N, and then the factorial thing.
No, C
Oh, that.
and X. Okay? That's what comes next. Right? Gabrielle.
Can we do it like the n factorial way? If that
Okay, if I'm going to back off just a minute.
Okay,
If you want to do that, you can.
okay, that's what I thought.
All right. I don't. Okay, so I got this. What comes next after that? Elena, can you tell me what happens after that? Okay. Reasonable. Liz Stanish. Okay. Mariah.
Times P to power X times Q with the.
To the power of, yeah,
Power of n minus x.
n minus. All right, Liz Stanish, does that look familiar? Okay. Elena?
Yeah.
Okay. This is the formula. I will give you this formula on the test. You don't have to memorize it. But you need to know how it works. You need to know what to do to put it in. And how that can happen. Sure. Rachel, can you tell me what I need to do to put the numbers in here for this?
Well, you do on a calculator, 10, CR, and then 3, get that answer, times it by 0.7 to the third times 0.3 to
7. Okay. So if you put this into your calculator, and this is being multiplied, this is also being multiplied, you should get 0.009. If you don't know how to get this on your calculator, we want to fix that right now. I want to find out what buttons you are pushing so that you are getting this answer, or if you're not getting it, what's the problem? Okay? So you need to know where this is on your calculator in C3. Or if you really want to do n factorial over x factorial n minus x factorial, then you need to know how to do that. I don't recommend it. I recommend using this on your calculator. And if you can, find this, hit those buttons, make this happen, and get 0.009. That's what I want. Okay. Anybody have any questions for me on how to make this happen?
Can we do one more example?
Sure we can.
Why don't you recommend the other one?
It's more buttons to hit. Okay? Do another one. N is equal to 8. Now, as you go through the process of doing this, you should not write down anything more than what I have written on the board right here. You should not write down all your intermediate steps in doing this problem, because that can be really confusing and there's a lot of decimal places and it's just too much work. What you should do is you should trust your calculator and your ability to check what's in the calculator. So when you put this into the calculator, you don't just stick it in and hope it's best, but you actually look at what's in the calculator and see if it is correct. Then you hit equals, and then hopefully you get 0.7229. Wow. Not bad. All right. Question.
How many decimal places should we go to? Or
You should go to whatever you're instructed. All right. Technically, by the way, technically, it really does depend on your purpose. If you're asking the question, for example, is this bigger than 0.5? It doesn't matter. Oh, it's bigger than 0.5. If there's some other reason why you want to go out, then you would. Usually. Okay. All right. What needs to happen right now is that if you don't have this number in front of you on your calculator, that's a problem that I would like to fix. But if you have this number on your calculator by going through this process, then we're good. Right? Now it's possible for me to go all the way around the room and ask each individual, do you have this number on the calculator? And then you would say yes or no. And then I would say, okay, if you don't have it, then I want to find out what's going on. But I'm going to allow you to ask questions if you need to. Right?
Okay,
Crystal.
so Tia tried to explain it to me, but I'm just like not understanding, I guess. Okay, so 56, something has to add up to 100 and something has to add up to 8. So where's 56?
Okay, hang on. What is the question, right? So here's my thing. Okay, what's n? 8. What's x? 3. What's p? 0.14. What's x? 3. What's q?
Is that the 56?
What is q?
1 minus 0.1.
1 minus p. Q is 1 minus p. Okay? So if this is 0.14, Q is 1 minus 0.14, which comes out to be 0.86. Okay? Do they add up to 100? Technically, no, they add up to 1. 0.86 plus 0.14 is 1. But if you're using percentages, it'd be 14%, 86%. Okay. What's n minus x? 5, because it's 8 minus 3. So when we do this, I get 0.14 to the 3, 0.86 to the 5. These exponents will add up to be 8. And these probabilities will add up to be 1. Okay, does that make sense?
Yes.
Okay. All right. Other questions? Yes. Sure. Let me see your calculator. Okay. 10C3. Put in 10.
He's like already full of color stuttering. He's a ring bear. Yeah. He's so cute. He's a ring bear.
All right, does anybody else have any other question about this so far? Okay, if you're not getting this number, then I would like to help you to get it. Okay. Now, as I said previously, getting this number is the first step in making progress. Understanding what this number actually means is a different thing, and it might not make a lot of sense right away, but over time it will become more reasonable. Okay? So, this is what I want. I would like for you to take a look at what we said previously about this. Look at your notes from the previous session where we talked about this. I do not want you to write down what I'm about to say. I want you to read to me what you've already written down of what I'm about to say. Okay? What does n represent? Sample size. What does x represent?
Is it sample proportion?
No, it isn't. It is the thing that we're measuring. Yeah. Is that what you're measuring? Okay. It is the thing that we're measuring, but I want to know what that thing is. Okay, this is our measurement. This is the thing that we want to measure. But we still don't know what it is. What is it that we're measuring?
The number of people saying yes to the number of things that happen.
Okay. The number of people saying yes. number of people saying yes. Well, what does that assume? That's also true, but that's assuming that we're asking people questions, okay? So we have to have a group of people and we're asking them a question which can either be answered yes or no. Because this is what we're measuring, the number of people saying yes. So that means we have to be asking them the question and they have to be able to answer either yes or no. It could be people, it could be businesses. When we ask the question, how many businesses are profitable? They can either be profitable or not. If we say, speedometers, how many speedometers work? They either work or they don't, okay? So it's not always people, and it's not always that they're talking and they're saying yes. So then another way to say this is the number out of n that are in a category. So we ask a question. Have you been to the hospital? Yes. Did you watch the NBA finals? Yes. Is the speedometer working? Yes or no. Okay? So those are the things that we mean when we say this right here. Okay. What does the letter P signify?
Probability.
It is a probability, but what kind of probability is it? Okay, go ahead.
General probability?
It's called general probability. Yes, it is. That's a descriptive word for it. It is also called the population or proportion or probability, whatever you want to call it here. Okay, general probability, population proportion. Okay, those are the names of it. But I need to know what is the description of it. This is not easy. I'm not expecting this to be easy. But since I did say it previously, I hope that you wrote it down and you can say it back.
Is it the probability of people saying yes?
Yes, it is the probability, and specifically of each person saying yes. Now, if you look at the practice test, this is on there. So you need to know this. You need to understand how it works. If I go to a conference of 100 people, and I'm wondering how many of them have ever taught an online class, N would represent the sample size, the 100 people. X would represent how many people out of that group have taught an online class. P would be the general probability, which would be the chance or the probability that each of those people would have taught an online class. So it would be something like, well, I know 60% of all faculty have taught online classes, so that's what I would expect it to be when I go to this conference, that I would expect this P to be 60%. So I want for you to understand what these things are actually telling us, and then to understand how it goes to our general idea of statistics. We want to find out what to expect. So we are measuring here the number of people that are saying yes. And so the question is, how many people can I expect to say yes? That's what I'm concerned about. So, let's go back to this one right here. So let's say I have 8 children and the chance of them having let's just say dehydration is 14%. Then what would this number be telling me? This is the general chance, or the general probability. So I have children in some kind of situation, I don't know what it is, but the chance of them being dehydrated is 14%. That's just a general statement that I get from outside my situation. Somebody told me that children in this situation have a 14% chance of being dehydrated. So what do I expect from these 8 children? No, that's not exactly correct. Because I have 8 children. If I did my 0.14 times 8, that wouldn't give me a whole number. So that won't tell me exactly what I could expect. Gabrielle, you want to?
Isn't it like each of the 8 children has a 14% chance of being dehydrated?
Yes, but my question is, I want to measure the number of children that are dehydrated. What would be the measurement of the number of children that I expect to be dehydrated? Out of those 8, do I expect 0? Do I expect 8? Or do I expect something in between? That's the question that I have. How can I resolve that question? I can use this. Right now, I'm looking at 3. Will I be surprised if 3 of these children are dehydrated?
No.
Okay, we went with yes, and then we went with no. Okay.
Maybe.
How do I tell? How do I know if I'm going to be surprised by anything? What am I looking for?
Less than 5%.
If it's less than 5%, it would be a surprise. Is this less than 5%? No. Am I surprised? No. I would not be surprised if 3 of these children were dehydrated because this is more than 5%. That's what this is telling me. That's what the process is about. The process, and you don't have to understand this totally right now. The process is, I want to figure out how many children out of the 8 are going to be dehydrated. If I had 3, I would not be surprised because this is more than 5%. Okay. But this is what I would actually get. This is a graph of all of my probabilities. The probability of 3 is in pink here. I would not be surprised if 3 of them were dehydrated. What about 0 or 1 or 2? Would I be surprised by any of those? Well, the 0 probability is 30%. 1 is 39%. This is 22%. So none of these would be surprising. If I'm asking the question, how many of these 8 children are dehydrated? 0, yeah. Or I could have 1 or 2 or even 3. I would not be surprised by any of those numbers. Could I have 4? Well, that's only 1% chance. Could it happen? It could, but I would be surprised. So what we're saying, again, the general chance is 14%. What do I expect out of the 8 children? X is equal to 0, 1, 2, 3. What would be my unusual values?
4, 5, 6, 7, and 8.
Okay. So this is what I want to be able to figure out. I want to be able to figure out what to expect when I have this situation. I have a group of a certain size. I'm asking a yes or no question. And I know a general chance or a general probability for each one of them. And now I can figure out my measurement that I'm interested in is how many of those 8 children will be dehydrated. It could be 0, sure. It could be more than that. I don't know. But according to this, these are what my chances are of this happening. I'd be really surprised if it was 4. 3, well, it's a little bit on the low side, but yeah, it could happen. Okay. So I just want to mention one thing to make sure that in the future that you understand what I'm talking about. If I did have 3 children with dehydration, this is my sample proportion. This would be 3 divided by 8. What's 3 divided by 8? So it's about 38%. So my general chance of children being dehydrated was 14%. But in terms of my sample, it could be anywhere from 0 to 38%, and I would not be surprised. So even if somebody says, I know that 14% of children have dehydration in this particular setting. When I have these 8 people in front of me, it could be anywhere from 0% to 38%, and I would not be surprised by that. Because it's a sample. Samples change. They have variation. That's what's going on right here. Okay.
Is that,
Question.
is that based on because you found that X 0 to 3 was expected, so then you?
Yes. And in a week, we'll make this much more. All right. Now, what I have just shown you is a version of the table that's in the textbook. There we go. Here's the table, which is in the textbook. If you were working on your homework and you click on tables, you would find this, not on the first page, but on the second page, third page, so on. Okay? This is a table of probability based on what we're talking about, which is binomial, okay? This is all binomial. Binomial means we're asking yes or no. So in my previous problem over here, this had n equals 10, x equals 3, and p is equal to 0.7. If I go to n equals 10, x equals 3, and p is equal to 0.7, that's this number right here, 009, which is what we got. Okay? So, what I want you to understand is how to look at the table and figure out the unusual values. Very similar to what we just did right here.
Are we gonna have the tables for the test, or do we have to do the other way for the test?
There is one question that has a table, and the table is on the test. There's another question that does not have a table, but you'll have a formula for that. This is also true on the sample test. If you look at the sample test, you will see there's a little piece of the table that's on there. And the question has to do with that piece, okay? You don't need to have the whole table, just need a piece. Okay. So, let's say that I have 10 computers. And the general probability that they need updating is 70%. So many different ways I can do this, but I'll do it the easy way first. So I have 10 computers. The general probability that they need updates is 70%. For whatever reason, somebody out there told me the chance of a computer needing an update is 70%. I have 10 computers. I want to have an idea of what to expect when I walk in the room. How many of the 10 will need to be updated? And I'm going to use the table for this. I have 10 computers, that's n. The probability that they need updating is 70%. So the question is, what am I going to look for? And what is my answer going to be? Okay, so I'm going to be looking for probabilities here that are above 5%. What do I see here which would be above 5%? Okay, these starting here and going up to here, but not that one. Okay, so how am I answering this question? I'm looking for probabilities that are more than 5%. And then the answer that I want is the X value that corresponds to those probabilities. Because the X value is what I'm measuring. How many computers need updating?
Can we list it just like that? So
We
the
can.
X equals 5, 6, 7, 8, 9.
We can. So when we look at the table, we're looking for probabilities that are more than 5%. And then we're looking for the X values that correspond to that. And that's the answer to the question. I'm interested in how many computers do I expect to need updating? 5, 6, 7, 8, or 9? What would be a surprise? Jordan,
I have a question going back.
that's fine.
Why not 10? Is it because there's 10?
If I look at the probability for 10, it's 0.028, which is less than 5%.
Oh.
Okay, good question. So now, what would be a surprise in this setting?
1, 2, 3, 4,
0, starting with 0. 1, 2, 3, 4,
10.
and also 10. Another word for surprise would be unusual value. What would be my unusual values of X? If I walk into the room and none of them need updating, I would be surprised, even shocked, because it's supposed to be 70%. And I walk in and all 10 of these computers, they're all been updated already? Well, somebody must have been here before me, because it certainly doesn't go along with what I was told. And the other thing is also true. If I walk into the room and I say, all 10 of these things need updating, it's only supposed to be 70%, it's not supposed to be 100%. I'd be surprised if they all needed updating. It's not supposed to be 100, it's supposed to be 70. But it could be anywhere from 5 out of 10, which would be a sample proportion of 50, to 9 out of 10, sample of 90. So even though the general probability is 70%, the sample probability could be anywhere from 50 to 90%. Okay. Now, what this is assuming is that that 70% number is a good number. Somebody told me something that was true. And that all of these computers, it's not like they're all interconnected to each other and they're all infecting each other or something. It assumes that each one of them is a separate event and each one has this 70% probability. Which doesn't always happen. Like in terms of dehydration, would it be the case that if one child is dehydrated, it's more likely that the next one is also dehydrated? Well, if they're like all involved in a certain sport, then yeah, it makes sense that they would be dehydrated. But if they're just randomly chosen somewhere, then no, that wouldn't make any sense. So all these numbers are based on the idea that each event is not affecting any of the others. These are just random choices. If these children that you're talking about are not randomly selected, but they just got in from recess, well then of course, dehydration might be present. So how to understand this, these are all mathematical descriptions of choosing random things like flipping a coin, but we're applying them to say that the general probability is true for each person separately. All right, so there's that. Now, I'm just going to show you what the practice test looks like with regards to these things. So, if we go to the practice test, and we're looking at these specific problems, okay? Question number 5. consider a survey asking students if they have attended in concert. That's what we were talking about. What does N mean? What does X mean? What does P mean? From the table at right, find unusual values of X. Hopefully it looks very familiar, right? We have 10 of them. And if we say unusual, they'd be less than 5%. And all of those. It's very simple. What we just did. We're going to skip number 7 for now. We're going to go to number 8. If the general probability for each of the next 5 days is 35%, find the probability of getting rain on 3 of the 5. So what you would have to recognize from number 8 right here is that N is equal to 5, P is equal to 0.35, X is equal to 3. And so you'd use this formula, which is right here. You put it into the formula, you get that answer. All right, so any question about any of these specific problems or anything else? Yes.
So on number 5, what exactly is the sample size 10 or is it just 10?
Okay, when we're asking about number 5, this problem right here is not connected to this thing over here.
Oh,
This is for number 6.
okay,
This is just number 5.
okay.
What does that mean specifically for this situation?
I don't want you to say that N is sample size. I want you to say that N is the number of people that we surveyed about this question.
Oh, so we don't.
I
have-
don't want you to say X is number of people in a category. I would want you to say the number of people who said they attended the concert. I don't want you to say P is the general probability. I want you to say P is the probability that each student has attended a concert in La Crosse. Okay, that's very important. Thank you for asking. Because I don't want you to just give back to me my definitions for this problem. I want you to use those definitions in a specific situation where somebody is asking questions. And I want you to tell me, for that exact situation, what do those symbols mean? Okay? So that's what I want for that. All right. Sure, yeah, we can take a break right now and come back at 1:40. And then we can talk about the rest.
Sure.
In this chair. But I don't know that I should get rid of it. Actually, take somebody else. Well, I'll just have to let this. Yeah.
I just have a question. Do you have my test
Okay.
graded from last week? 'Cause I missed it.